by Divesh, about big data linkage of product specification pages.
Okay, I'm Divesh. If you listened to my 1-minute talk earlier this morning, that was supposed to be an advertisement for this presentation. This is a short talk. It's an advertisement for going to read the paper. Okay, so if you're expecting to get any real information from this talk, you might as well leave now. So this is joint work with a bunch of colleagues from Rome and Brazil. What I'm going to talk about is a very simple problem, which says, so I talk about big data linkage for product specification pages. So very quick thing, what are product specification pages? You know, there are a lot of pages out there which give you information about one product, gives you a lot of different attribute value pairs for this, and this is available for products, organization, people. So we just call them, you know, specifications. And you can think of a product specification page as just a web page which has these kind of specifications present in there. Okay. So in previous work, using the Dexter crawler, we were able to crawl about, you know, more than 1 million, about close to 2 million product specification pages from several thousand sources. And this data set, you know, to anticipate Erhard's question, is available publicly already, right? And so people can use it. And so we decided to use that data set as well to try to understand how can we support linking. Okay, now what we observed was that the same product specification was often available from many, many sources. Okay, and being able to integrate across these sources would enable a lot of different applications. So we would like to be able to integrate this. But a common way of integrating is to first do schema alignment. And given the large number of sources that we have, right, and the very heterogeneous way these sources represent this, we couldn't figure out sort of a good way of doing schema alignment before trying to do any linking. Okay, so maybe just our limitation, but there was sort of several thousand sources. Trying to figure out every pair of possible source pairs to do schema alignment just seemed quite infeasible to us. So what we decided to do was to adopt a different approach, taking advantage of the possibility that most of these products, right, actually are named entities. They come with IDs, right? And this is an observation that I think Erhard made about 5 years back in a paper of his, right? And so if you look at the variety of different, if it works or not. If you look at the different kinds of IDs that are present here, right, you know, there's just a very wide variety of IDs, and they are not always present in structured attributes. They might be present in the title, they might be present in some other part of the text. So the idea, a very interesting insight that we had was, if we could not do schema alignment, we might still be able to link pages across sources by extracting, by discovering the IDs from those pages, right? And then providing a mechanism to link different pages by finding pages with the same ID of that page. Okay, so we can end up with doing that. There are challenges, right? So we went from the challenge of saying, you know, we couldn't do schema alignment effectively to saying, let's do stuff with IDs. But even with IDs, there are challenges. So for instance, the fact that IDs are not necessarily present in structured attributes, there's a large variety of IDs, right? People think product ID, think UPC code, think G1013. We did an analysis, very, very few products in practice actually adopt those codes. Okay, there's just a lot of manufacturer codes, a lot of things that are present in many different formats. So this made it very challenging to discover IDs in product specification pages. But as you can see, some of these pages are also fairly complex. So the IDs could be present in a lot of places, right? So given this complexity of the product specification pages, discovering the ID of the page, okay, as opposed to simply discovering IDs in the page, is also challenging. Right? In a page, you may have an ID of the page, of the product in the page, but there might be IDs of related products, products that you might want to buy as accessories, right? And you have to be able to distinguish all of these. So given these challenges, we sort of observed that actually there were many interesting opportunities as well. It's not merely challenges, right? So this is a general theme that in big data integration, it comes with many challenges, but there are typically many interesting opportunities. And two opportunities that we found, one said that these IDs are highly redundant, especially for head products. Right? So the same ID of the product may be present in many, many sources, and we want to be able to take advantage of that. The second is, even though individual product specification pages might be complex, right, it turns out that a source is typically homogeneous. So if I have a set of products of a given type, of a given category, the products in that particular source tend to be all homogeneous pages. So the advantage of this is that with the ID redundancy, we can generate some kind of an effective iterative approach, right? You start with a known training set of a few IDs, see where they occur in the page, right? Be able to parse the page using and generate extractors, right? And then iterate. Look for those IDs in other sources, see where they appear, generate extractors from there, and keep iterating, right? And what we observed was that in general, it gives you a good recall, right? But in order to find high precision, you need to make sure that you found good extractors. And we took advantage there of the duality between good extractors and correct IDs. And finally, in this thing, we used an idea of product co-occurrences to be able, across different sources, to find linkable IDs. And the reason for this is there are IDs of many types. Things that are global, right? But there are also local IDs provided by each source, right? And these are not really supposed to be linked across sources. So you want to filter those IDs out as well, and we were able to do this using some interesting techniques. So if you think of what I just talked about, right? Think of parsing a page, using some IDs, doing it repeatedly. You can think of it as being very expensive, right? Because I'm repeatedly parsing every time I discover new IDs. So the question is, how do we do it efficiently? Right? And the observation that we had was that we could actually take advantage of the fact that many of these things are head sources having a lot of products, and there are a long tail of what we call tail sources. But also we have head products, products that appear in many sources and products that appear in few sources. So by taking advantage of how we prioritize the iterations between looking at head products and head sources, right, running the iteration over those, and then propagating it to other kinds of sources, we could end up with a considerable efficiency. So we start from here, move on to here, finally end up here. So we don't end up looking for tail entities necessarily across sources, but we just link using head entities. Okay? And doing this iteratively allows us to get a lot of efficiency. There are many, many results in the paper, right? And since I'm coming to the end of my talk, I just want to give you sort of a quality result, right, as opposed to an efficiency result. Using our approaches, we were able to get across, as we said, over 1 million pages, several thousand sources, about an 80% recall, F measure. Okay, the recall is much higher. The precision is not as high, right? Again, because of the very, very different nature of IDs that exist in practice, and also other things, right? We look for IDs which are primarily single tokens, right, single words. Sometimes you find things which are multi-words things, and our current technique cannot sort of find those. And we are in general doing better on head identifiers than tail identifiers. This gives us sort of opportunities for future work. So to summarize, right, we propose an effective and efficient solution, right, that essentially allows you to do linkage for product pages before you do schema alignment. So that's not the normal flow, right? But using this linkage, we can actually do better schema alignment in the future, and that's part of the future work that we'll just mention. Right? There are interesting challenges as well as opportunities, right? And the key takeaway, right, is that very often people look at redundancy of information and say, more data to process, this is such a big pain. But turns out redundancy in general should be viewed as a friend, because you can take advantage of it to get improved quality results. And so that gave us the name of the project, the RAF, which was Redundancy as a Friend. Right? Thank you very much. You'd rather go for lunch than ask me a question?
I could ask a question, but I think we do it offline. So thanks again to Divesh and all
Thank you.